In this unit, we're going to discuss different properties of gases. And the first thing that I need to talk about is a pivotal theory that we're going to be using throughout the unit, even though we might not reference back to it. But these are 4 assumptions that we are going to be making about gases and how they act. The first is that gases are a collection of particles that are in constant motion. They're constantly bouncing off of each other. They never stop moving. That's also true of all states of matter. No particles within a solid, a liquid, or a gas ever stay still. They're constantly moving. So that's the first assumption. Second one is that there is no attraction or repulsions between the particles. So when gas atoms hit one another, we're assuming that they're not attracted to each other at all, and that assumption is not 100% correct, but it enables us to do the work and the calculations that we're going to do in this unit. The third assumption is that there's a lot of space between the particles compared to the size of the particles themselves. Meaning, if you look at this diagram right here, there's a ton of space in between the gas atoms. And that is what is a characteristic of gases, the fact that there's a ton of space in between the particles, all right? And that allows us to compress the gas later on because there's so much space that can be decreased. The fourth assumption is that the speed of the particles increases with increasing temperature. So when we increase the temperature of gas molecules, what's actually happening is that their kinetic energy, their energy of motion, is increasing, which makes them speed up. In this lesson today, we are going to look at 2 different measurements that we can make for gases. The first one is pressure. Now I'm going to give you the official definition of pressure, and then we'll discuss it in more detail. Pressure is the force per unit area that results from the collisions of gas molecules with their surroundings. So a good example for understanding pressure, if someone steps on you with stiletto heels and then steps on you with tennis shoes, the one that hurts the most is the stiletto heel. And the reason why, they're exerting the same amount of force on you because that person weighs the same amount, but the unit area for the stiletto is so much smaller that as a result, the amount of pressure they put on your foot when they are wearing stiletto heels is much greater, and that's why it hurts so much. Now, you deal with pressure every single day in your lives. You deal with atmospheric pressure. So if you think about it, all the gas molecules in the air, they're actually pushing down on you. The interesting thing to think about is the difference in atmospheric pressure between high up on a mountain and low down. If you think about when you're at sea level, there are more gas molecules that are pushing down on you as a result, so the atmospheric pressure is greater than if you're at the top of a mountain. As with any other concept that we've studied this year, as soon as we come up with a concept such as pressure, we need to be able to quantify it. And so as a result, we've got 3 different units that can be used to measure pressure. The first one is atmosphere. So 1 atmosphere equals, there's 2 other units that can be used. So the first unit is going to be millimeters of mercury. So 760 millimeters of mercury equals 1 atmosphere. The other unit that can be used to measure pressure is kilopascal. So 101.3 kilopascals equals 760 millimeters of mercury and equals 1 atmosphere. Now, where these values came from, What was discovered was that if you're at 1 atmosphere, what scientists did was they took a tube, they filled it up with mercury, and then they inverted it so it's an upside down test tube basically. Okay. If you're at 1 atmosphere, meaning that there's 1 atmosphere of pressure pushing down on the mercury will rise to a level of 760 millimeters of mercury. So that's where they came up with this unit, the unit of millimeters of mercury. We're now going to do one setup problem for showing the conversion between units of pressure. I'm going to start it out. I'm going to write out the setup for you, and then you will solve it. So if I start with 1,277 millimeters of mercury, and I'm asked to convert to atmospheres, I'm going to put millimeters of mercury on bottom to get rid of it, and I'm going to put atmospheres up top, ATM. Okay. Now just remember the relationship between millimeters of mercury and atmospheres. 1 atmosphere equals 760 millimeters of mercury. So what you need to do is take 1,277 and figure out if you need to divide or multiply by 760, and then have the correct number of significant figures. Now that we've talked about pressure and units of pressure, we're now going to relate that to one other measurement in this lesson, and that's volume. The relationship between pressure and volume we call Boyle's law, and I will write that out in one sec. What I want you to do right now, though, is look at the diagram that I provided you. You start with a gas within a container that has a large volume, a volume of 4 liters, and its pressure is 1 atmosphere. If I decrease the volume, which I can do because gases are compressible, what happens is the volume decreases, but notice the pressure increases. So an easy way of putting this is that when volume decreases, pressure increases. So when one goes up, the other goes down, or when one goes down, the other goes up. This relationship is an inverse relationship. And so what Boyle's law allows us to do is use this concept and apply it here. So if I knew that my volume decreased to 2 liters, using Boyle's law, I can determine what the new pressure will be. And so the formula for Boyle's law is the following. Your first pressure times your first volume equals your new pressure times your new volume. So in the problems I give you, you'll be given 3 of these values and asked to solve for the 4th. So let's look at an example really quickly. It says a balloon contains 30 liters of helium gas at 103 kPa. Remember, that is a unit of pressure. What is the volume, meaning the amount of space it takes up, of the helium when the balloon rises to an altitude where the pressure is only 25? So I start off, and I know that my initial pressure, my P1, is 103 kPa. And I'm going to include units because later on, if your units don't match up, you're going to have a problem. Okay? Times my initial volume, which is 30.0 liters. All right. Now, if the balloon rises so that its new pressure is 25.0 kPa, notice my units of pressure match up, kPa and kPa. What it's asking is, what is the new volume? So before I do this calculation, what we can see is, okay, if pressure decreases between these two, what that should tell me is that my volume is going to increase. So when pressure decreases, your volume should go up. So if you actually calculate it out, you can solve for your volume. And I'm going to ask you guys to do that without my help. Do keep in mind that the units for volume are going to be liters. Okay? So calculate your new volume.